Well, sorry, I got distracted watching some videos. People talking. Welcome to our YouTube video for May 7th. Goodness, we're in May. Yeah, quick start. Just not showing up here yet. Sorry, pulling up chat so I can see if anybody's talking to me. It's 2 o'clock. We're going to talk about some math today. Hopefully, we'll see how long. Not super complicated today, but it's going to be kind of the foundational thing that we use for the rest of the chapter when we're talking about trigonometric functions for Algebra 2. Okay, so if you remember back Tuesday, we talked about sine, cosine, and tangent. We talked about cosecant, secant, and cotangent, and that order just helps us remember which ones kind of match together. I feel like I didn't do the best job on Tuesday. Sorry, didn't do the best job on Tuesday. We will revisit those things. They're going to be continual in all the things that we do going on, but we'll probably go back to them next week, especially because I wanted to talk about radians, and then we'll use the trig functions sine, cosine, and tangent with radians. So today, in our chapter 9 preponderance, is going to be all about what a radian is, how can we turn degrees into radians and back and forth, what that looks like, what it means, and how you've already really been using them. We're just labeling it by a different name because it makes our trig functions way easier. And my video's lagging, and I don't know why. It is what it is. So before we do that, I'm going to pull up this window. So we're in chapter 9, 9.2, and we're going to go to this first. Okay. So since 7th grade, man, I don't even know when you start learning about degrees. You've been learning about degrees, right? So like 45 degrees, or 27 degrees, or 430 degrees. And you know that to be the size of an angle. We want to redefine some things. We're going to be working in the coordinate plane a lot for these. Before we get to how to graph a sine, cosine, tangent function, or any of that kind of stuff, we need to take these degrees and convert them into radians so that they fit on our graph well. And we need to understand what those degrees mean and how it relates to radians. So first, when we're talking about angles, we're going to start by placing our angles in the coordinate plane starting at the origin. And so they're going to go up like this. That's a 9. Let's say that's a 190. It doesn't matter what degree that is. This has a degree measurement. Right? It's an angle theta we've been using. And it would be in degrees. Okay? And that just tells us the direction. Like how far up we're looking, right? When we look at our textbook, and this is page 469, there's a chart right here which has a bunch of circles with all these degree measurements, and they're in the coordinate plane, right? This here is x, and then this is our y-axis. Right? So we go over x and up y. And we're trying to figure out, like, how do I turn that kind of over and up into that rotational thing? Eventually. Not right away, but eventually. Okay, so our angle is in the coordinate plane. It's starting at 0, 0 here. Now we're just going up and down. Okay? And we have some special names for things. Okay, so we have 2 types of angles. So this is standard position, is what this is. Standard position starts at 0, 0. For some reason, my hand video. That's my phone. I don't know why it's lagging. Maybe. It seems better. Don't know. So standard position is centered here, and that would be this page of the book. We're on page 470. Okay, so standard position. centers the angle at 0, 0. That's where the vertex of the angle is going to be. Okay. And we have an initial side and a terminal side. The initial side is the side that lines up with the x-axis. That's this side, initial. And this would be terminal. Terminal meaning where it ends. So it's the terminus. Be a word. Terminal. Where it ends. And clearly my handwriting isn't improved, but it's what my mouse is. Okay, so that's standard position. And then we have two types of angles from the one standard position angle. These are called coterminal. So coterminal. Co meaning with, and so it means with the terminal side. In other words, they both end up at the same place. If I go up this way, I can reach this terminal line if I also go all the way this way, right? Those two angles are going to be the same. They're not the same angle, but they match the terminal side. Right, so I have this obtuse angle, and I have this acute angle, and they both have the same terminal side. You've been doing this before. We haven't thought about it or used this language. But basically, we take our theta, and we take 360 minus theta. Those are our two coterminal angles. So say you had, I don't know, that looks like 40 degrees. So it'd be 40 degrees and 360 minus 40, which is 3, 1. And those two angles together would make the full circle, right? So we have our angle and we have our coterminal angle. Okay, so that's the first piece. And then in your book, you have some examples about finding coterminal angles. It's basically what I just did. You have a positive angle, and then you have a negative angle. A negative angle. Oh, sorry. So this angle here is going to be negative. It's 320 degrees, but the negative tells us the direction that it's going. Well, it should be negative 360 plus 4 or whatever. So our answer is going to be negative, and that's because this is going in a negative direction this way. So it's okay. So that's how you're going to get negative angles and how they would show up kind of on the coordinate plane. All right. So that's terminal and coterminal. That has nothing to do with radians. Radians are going to be a way to measure the distance around that curve. So when we're looking here, see, this is my angle. Here's my thing. We would talk about this as degrees, theta degrees, and then this is radians. They're the same, but they're also different. Okay, and radians are in pi measurements. Use pi. So 360 degrees, this is in degrees, is going to be the same as 2 pi radians, or rad. Radians. 360 is the same as 2 pi. Now, that's not the most useful formula, not when we're talking about converting, but this is the definition of what radians are. Okay, so when we're talking about a circle on our unit, we go all the way around. This would be 2 pi. And the reason we use these is because then we're not locked into degrees. There's only 360 of them. But also because when we're thinking about circumference, it's 2 pi times r, right? Circumference of a circle. When we're talking about the distance around the circle, if it's 1, radius 1, then it's 2 pi around. And so that's the kind of unit we're measuring. We're measuring around the circle with the radius 1. And this radius 1 circle is going to apply to every single circle. It doesn't have to actually have a radius 1. but we're imagining a radius 1 circle. And we're going to use that unit circle, unit being 1 radius, later when we're talking about sine, cosine. But for now, we're just going to talk about radians. So we can simplify this 360 and 2 pi. We can simplify it to be 180 if I divide by 2 on both sides. This is going to be 180 equals pi. And this is going to be the formula we're going to use. Okay? 180 equals pi to convert. And if I divide by pi on both sides, we get 180 divided by pi equals 1. Or if I divide by 180 on both sides, we get pi over 180. These would be the same, right? Now they don't look the same, but it's because their units are the same. So this would be rad over degrees, and this would be degrees over radians. And the reason that we would use both of these is we're going to convert an angle measure to a radian measure. Okay, so I'm going to rewrite more of the formulas up at the top, and we will talk about how to convert. So 180 over pi, or pi over 180. If we're going from degrees to radians, we're going to use this one, pi over 180. And if we're going from radians to degrees, we would use 180 over pi. Okay? So what if we want to turn 40 degrees into radians? Well, we would multiply this by pi over 180 degrees, and now the degrees cancel out, and we're left with 40 pi over 180, and we'd plug that into our calculator and get whatever we get. Or we would write it as 2/9 pi. So we can simplify that from. Yeah, 2/9. Okay? Or if we want to turn our radians into degrees, if I have, I don't know, 1.5 pi, we want to turn that into degrees, that's in radians. We would multiply this by 180 and divide it by pi. So the pi's cancel out, and we're left with 180 times 1.5, which is 270 degrees. We end up with degrees. We started with radians, and we end up with degrees. Okay. In the Dropbox folder, I uploaded a student journal that looks like this. Okay. And so we have our unit circle, and we would change all those degrees into radian measurements. Or we could turn the radians into degrees, talk about how we can go around the circle over and over and over, and then a bunch of things that I already talked about. I didn't really talk about sector or central angle, but it's okay. Stand position gets mentioned. We have the formulas. We have our special angles. This circle right here, this circle, I don't really have a good way of selecting it, but this circle is going to be really important. If we were in class, you would have memorized it. We would have spent the time to memorize that circle. Memorize it, basically. And so it's 36, it's increments of 30, 60, 90, and then the 45s. So 45, 90, 135, 180, add another 45, add another 45, add another 45, 360, and then it would just repeat over, and so we don't keep track of that. And then we would talk about the 30, 60, and all those things, and how they're broken up into sixths, and so on. Because it's a sixth of, a sixth of 360. No, that's okay. 12. It's 3. Whatever. Anyway, fractions are on the thing. Okay? And then in geometry, at some point last year or year before, you would have learned about arc length and area of a sector. Not really going to cover this because this is not what's important to me in this chapter. But you can calculate those using radians There's a formula. Not super worried about that because we're going to focus on the trig functions. And we don't have as much time as we would. We're not spending as much time as we would in class. Okay? So, these extra practice ones, you don't need a compass for this. All you need is to approximate. So this first one, I'm going to do some of these problems. This first one says 270. 270 degrees. So 270 is bigger than 180. If I subtract off from 180, I know that my circle is going to go this far. My little arrow. The initial side's here, right? Going that way. And then the arrow is going to be somewhere down here. When we subtract this, we get a 90 left. So my circle needs to go another 90. It's going to be here, and this is my angle. We're just drawing it. Should be not that big of a deal. I'm going to do another one, not number 2, but let's do a negative one, where let's draw negative 200. Negative 200. So the initial side still starts here. Here. It's going to go negative, so it's going to go this way. And I know that it's bigger than 180. And then it's like a little bit. Probably not exactly that, but it's going this way. So that's 200. Positive 200 would have gone past and then gone near. Okay? So negatives start down instead of going to the bottom. Always going counterclockwise for these angles. Counterclockwise. Okay? That's number 1. Drawing some angles. And then this is just use the 2 angles. I don't want to do these. Yeah, they're easy. 3. The angle is 55 degrees. So we already have the positive angle. To find the other angle, we do 360 minus 55. 305 left. So our positive angle would be 55 degrees and negative 305 degrees. Those would both be coterminal. They would be somewhere. We have our positive angle and we have our negative angle. Okay, and then we want to convert. I can't scroll down anymore, but you can see the picture. We want to convert from degrees to radians and from radians to degrees. And I know this is in Khan Academy. So if you'd like, I should practice this because it's confusing. Khan Academy has more videos. I know there's extra practice in there because this is an important skill. So we have number 7. It's 54 degrees. We want to convert this to radians. It's in degrees. So we need to divide by degrees. So it's pi rad divided by 180 degrees. Multiply those. The degrees and the degrees cancel out. This is equal to 1, so we're not changing the value, even though it doesn't look like a 1. We're not changing the value of our number. We're just changing the units that it's in. It's going to be 54 pi over 180, and I'm sure you could simplify that. So 27 over 90 times pi, and then 9 out of both of those. 10. No, actually, it. Nine out of both of these is 3 over 10. So we can simplify the fraction. Okay? So this is the radians for how many degrees there are. And then, let's do one of these that's in degrees. Number 8 is negative 310 degrees. So to convert, no, wait a minute. Sorry. Let's do number 10 instead, not degrees. Radians. So this is in radians. This is number 10. Sorry. And we're going to multiply by 180 degrees and divide by pi radians. And you'll notice every time we do this, the pi in radians is going to go away. We'll just be left with a number. Might be a weird number, but it's going to be a number. So the pi's cancel out. We get negative 360 over 5, because 2 times 1 is 260. Divide by 5. Pi. Sorry, it's making the video rumble. Sorry about that. So then this, we simplify 72, I want to say? Yeah, so negative 72. Okay. That's it. Radians are just another way to talk about degrees. It's the distance around the circle. How far are we walking around the circle? Instead of like, how big is this? So I think that's it for today. I want to continue to assign what would have been homework. So you can think about those. I don't really care about you being able to draw them in standard position. I do want you to be able to do that, and I want you to be able to convert. So the assignment would have been page 474, and I'll put this up on the whiteboard in just a second. 9 through 20, all of the problems. So it would look like, not that screen, that screen. Okay, so 474, 9 through 20, all the problems. It looks like this, just 9 through 20. You'd be converting from radians to degrees, degrees to radians, and you'd also be like, find the angle that matches with that angle. Okay. That's it for today. 20 minutes. Good. Trying to make them shorter, quicker, kind of more to the specific thing that I want you to know how to do. Convert radians. That's what I want you to know how to do for these. And we would have spent time in class and probably done some computer stuff and all that kind of stuff. Calculator, really useful for this because you're just dividing it as time. Yeah. So we're going to use radians with sine, cosine, tangent. We'll get into that next week. But that's it for today. I don't see any questions in the chat. Yeah. My plan is to get caught up grading tomorrow. We'll see. I've had a bunch of people send me stuff. I had some people send me some study guides and stuff, some Khan Academy stuff I need to grade, some work. That's great. Keep sending me stuff in. It will get graded by the time it needs to get graded. And I will be sending an email maybe next week, this week or next week. Specifically seniors, you have till May 22nd. Yeah, sorry, Shane. You can watch it back. It'll be up on YouTube. You can watch it back. Sorry. It's short, man. We're getting shorter. I'm trying to make them shorter. Yeah. So seniors, specifically, you have till May 22nd to get your grades in. Because that's when grades would be going in anyway, because we'd be taking finals. And you'd be done. So rest of us, I'm not sure what we'll do kind of after that. I kind of want to finish it all, and then we'll kind of figure it out from there, but it'll be fine. But seniors, you have like 3 weeks, less than 3 weeks. Look at my old calendar now. May 22nd is 2 weeks from Friday. Yep. 2 weeks from Friday. So I need to double reach out. You're running out of time. And honestly, like, there's not very much time, but there's a lot less work than there would have been, because if there wasn't coronavirus, we would have been doing new work to add on, and if you were way behind already, it's a lot easier to catch up now than it would have been, which is the good thing if you're a senior, or whatever, any grade really. But yeah, there's going to be a deadline. So we'll probably do a Zoom next Friday. I'll send a calendar invite for that. I'll send an email invite for that again. We'll do a Zoom next Friday, and I think that's it. good to talk to you guys. Have a good Thursday. Stay safe. Stay at home. Be wise. Get your work turned in. Okay? And I'll see you guys on Tuesday next week.